Suppose we have a drawer containing only blue socks and black socks, and we pick 3 socks without looking. Can we guarantee that we get either a pair of blue socks or a pair of black socks? So, of course, the answer to this question is yes. And maybe at an intuitive level, you can sort of think of the worst case. If you get a socks that will be of one color, then the worst case is that you get another socks of a different color, but there are only 2 types of socks, so when you get the third one, it has to be some color that already happened, right? You can also do it as a proof by contradiction. So let's write it here. So proof by contradiction. So suppose not. Suppose that this is not the case. So suppose not. Then you can have at most 1 sock of each color, right? Sock of each color. So one blue plus 1 black equal to 2 socks. But you picked 3. But we have 3. Which is more than the maximum of 2, right? Thus contradiction. So yeah, so at least 2 socks must share the same color. Now, this is the basic idea behind something known as the Pigeonhole Principle. It might seem quite obvious, but it's quite a powerful tool and can be used to prove many other things. So the Pigeonhole Principle says the following. If you have n plus 1 objects and you place them in n boxes, then at least one of the boxes must have 2 objects or more, right? And it's called Pigeonhole Principle. Sometimes it's stated in terms of pigeons and holes. So if you have n plus 1 pigeons and you have n holes, then there has to be at least 1 hole with more than 2 pigeons, right? And so again, you can prove this by contradiction. So again, let's write it here just for completeness. So we can prove by contradiction. And the way this would look like is, so suppose every box contains at most 1 object. So again, we want to prove by contradiction, so let us suppose that this is not the case. Let us suppose that somehow we were able to make it so that every box has at most 1 object. But then at most there can be n objects. There can be n objects placed into the n boxes. So if every box has at most 1 object, then if you sum over all the n boxes, you have at most n boxes. However, you have at most n objects. However, we have n plus 1 objects, which is a contradiction. So a contradiction. And so this proves the Pigeonhole Principle. And maybe the last thing I would like to comment here is that this is equivalent to also a statement about functions. So in terms of functions, this is equivalent to if you have a function from a set A to a set B, and the size of A is larger, strictly larger than the size of B, then the function, then f, cannot be injective. So remember, an injective function, everyone in B would have to be the output of some input in A. But A has more element, every element in B would have to be the output of some unique element in A. But A has more elements than B, so that's impossible. And so the pigeonhole principle is really just a counting version of the fact that there cannot be an injective function from a larger finite set into a smaller finite set.